I'm CK. Tonight we're going to be doing the 6th in Erica Synths EDU series. We'll be doing their mixer. I expect that their user manual will be as valuable as the other 5 have been, very valuable. And the module will probably be serviceable and relatively straightforward to put together. Hope you enjoy the video. Mix from Erica Synths, their EDU series mixer. Small box, plain and simple. Let's see what's inside. Let's take a look at the front panel and the circuit board first. Here's the front panel, and we've got 3 ins, 1, 2, 3, and input 1 level, input 2 level, input 3 level, out, clip out, and inverted out. That's interesting. Now we've got the board, and it's a good board. All through-hole plated. All the components have their values marked, except, now this is the problem, there's a bunch of stand-up resistors again, and I can't tell what the values on some of these are. We're going to have to look at their build guide or picture online. Little eurorack cable, and I'll continue to complain that the red stripe is way too light here. It's just dashes. You can't see that in the dark. You can't see that behind your panel. Let me get the box ready for recycling. Now this is funny. These bags are not their usual bags. See what's in the electronic side? Some things tangled up, some electrolytic caps, resistors, diodes, bunch of resistors. These are probably 104s, yep, 104 caps. Then we've got some 702s, TL0702s, so 2 op amps, a trimmer, and that's it. So it's a pretty simple build. In this bag are the jacks and pots, again, not many. So that's the way it looks. Let me get the soldering iron heated up, and we'll start putting this thing together. So the manual is what we expected, really good, with a really comprehensive description of how mixers work, what a mixer does, what the op amps are doing, inverting the mix, and adding distortion using diodes. So that's all pretty much fun. And again, if you don't buy the module, go download this manual from their website, and you will get a whole heck of a lot of value out of that. I'm looking through the build guide to see if there's anything in particular. Nice schematic. And then we do have a drawing, so I can find the values of these resistors, even though I'm still not sure. I don't know what this means. I don't know what R12OR, oh, there's 0R, and DNM. I'm not sure what the heck that means. I've got to look that up. Oh, and he did it again. I'm sorry, I'm going to complain about this again. In this guide, this picture, which is describing something or other, it's using a picture from the VCA. if they're gonna, he's describing the stand-up resistors, and he's using a picture of the circuit board from the VCA. You should always update to the product you're actually working on instead of using a generic one, simply because you're going to confuse beginners when you do that. So it looks like these DMMs, the DNM, are not actually used. Yeah, they're not used. There are 2 test points, and then there are these 1, 2, 3. I guess that means do not mount. First we'll start with resistors, and we'll do, what are we going to do first? We'll do the most populous one first, and let me check these to see how much slop there is in their value. These are 100Ks that are coming in at 99.4, and if I go to the other one at the other end, 99.5, so they're pretty good tolerance. So where do all the 100Ks go? There we go. So we start, we'll talk about one resistor going in, and I won't talk about the, we're going to do all the laying down resistors first. We're not going to do the stand-ups at this point, because we'll get some other lower height components in first. So we put the first one in and see how the leads go. So you have to have about 1.5 millimeters on each end to bend that down. And we'll go ahead and solder this one just to feel how the solder flows on this board. Flows very nicely, goes right down into the component hole very well, so that's good. It's a good board, as I mentioned earlier. Now I'll put the rest of the lying down resistors on in fast replay without commentary, because there's nothing much more to say about them. So welcome to resistor time for this evening. Ah, come on. This tape has got more adhesive on it than usual. Ah, come on, guys. We, of course, observe polarity on here. Oh, the leads fit through the holes pretty well. It can be challenging with these types of diodes because they're generally thicker. These 5819s. Now we got the 4148s, the little switchings. And they go down here and they alternate, black stripe here, black stripe there. So make sure you observe that correctly. Now we'll put our IC sockets on. And as first we make sure the notch is in the right place, even though as a rule, while I notice the notch on the socket, I'm always looking at this silk screen. God, I'm always looking at the silk screening on the board because sockets can be installed wrong sometimes. And the truth is on the board. So soldered one leg, and I'm going to see if it's all flat and down. It's pretty much down, but I'm going to heat that up and seat it a little bit more. Do the same for the other socket. And that one is pretty much up, so I reheat the socket, reheat the solder, seat the socket, and it's all good. I'm going to put all the ceramic caps on, the little 04s, the tenth of a microfarad buffering caps, smoothing caps, whatever you want to call them. In general, even though it's not always true, but in general, if you're trying to find out where these 104s or 103s go, always look near the IC sockets first, because they're often used to ensure that the chip doesn't get over voltage or under voltage. So they're very commonly found right next, as close to the socket as you can possibly get. On surface mount boards, it's even closer. Go ahead and solder these down. Now we'll do our stand-up resistors. And you take the resistor and you flop one lead over, and then you find the little circle where it goes, and this is 100K, so it goes here, and the body goes in the lead hole that's got the circle around it, and the other lead, you can see a little white line pointing to the solder point that the other lead goes into. I'm not going to give my usual rant about why I don't like stand-up resistors, but I don't. Now we'll do the electrolytic caps. These are 47 microfarad, 25 volt. Let's see how the caps are marked. They're marked okay. I don't really like them. The square pad for positive, the little flat line on the other side for the negative side. I do personally prefer software that puts actual plus and minus symbols on the board. I think that reduces ambiguity, but it's all about what your board software does. Now the last piece of control on this side of the board will be this trimmer, and very clear indication of where the screw is, which is nice. And again, I know it's not completely seated right now. I'm not going to fight it. I'm just going to solder one leg. I'll pick it up. You can see it's all off the board. I'm going to press it with my index finger, reheat that leg, let the solder cool, and it's all perfectly flat and perpendicular to the board. Now we probably want to put the power connector on now. Yes. So let's get that out. Now he shows a little notch on the board for the negative side of the power connector. Of course, there's no notch on the connector itself, so what we're going to do is we're going to take our power cord and look at where the red stripe is on that, because that's the negative 12 volt side, and we'll put it on the board like that. So now we know it is actually right, and when we connect power, because the connector is keyed, we know we won't get it wrong. That cool. See if it's all flat. It's not quite flat. Of course, I burnt my finger because the pins transmit heat to where I'm pressing on it. And there, that's all the component side of the board. Now we do have to put the op amps in, but I'm not going to do that yet. I'm going to do all the control side next, and then we'll put the op amps, the ICs on last, just to protect them. Now this is something I always do, and the author of this kit also reminds us to do. Just go through and double check all your solder connections, make sure they're all made, make sure there's no bridging. I use an index card to do this, so I'm only looking at one line at a time. I'm not overwhelming my brain, my visual system, trying to look at everything at once. Now we'll put all the pots on. I believe they're all the same. They're all 100K. I had to do simple arithmetic, and my brain locked up doing simple arithmetic. Does that. Oh man. Those pins are a little bent. Not too bad. Not as bad as I thought. And they thoughtfully took the panel nuts off the jacks before they packed them in the bag. I always appreciate that. Mainly I appreciate it because sometimes they don't do it and I don't notice, and I go to put the panel on and I got all the panel nuts I got to take back off. Okay, I'm going to take the front panel and lay it down on it for right now. Oh, that went on very smoothly. This is not going to be a problem at all. Sometimes boards fight you. This one didn't fight at all. So it didn't fight, but I'm still going to do my typical, going to solder one jack pin there and solder one jack pin at the opposite corner like that, and then double check that those are both flat, and then I'm going to take one panel nut on each of those, take it down finger tight, It's amazing how well I can cross-thread something just using my fingers. We'll snug that one down too. Now nothing's going anywhere, so we can solder these pins all up. Now we'll put the op amps in. Bend the legs in a little bit against the side of my workbench. Now this does not have a notch, has a little dot. It's got a, I don't think these are real TI parts. I think they're knockoffs. They'll work just fine. I mean, it's hard to get an op amp wrong electrically, electronically. Now we'll take the power cord again and plug that in. And that's the build. So here's the front, the side, back, other side, top, and bottom. And we'll put it in the rack and give it a test. Okay, we're in the rack, and we're in the dedicated EDU rack with the sequencer, VCO, VCF, envelope, dual VCA, and mixer. I've also got another VCO to mix in, because I didn't want to just do the waves from the VCO I have. So let me focus in on the mixer, or zoom in on the mixer rather. And we'll bring up the oscilloscope. Now, got everything down. I've got input from the VCO, a saw wave from the VCO going in, and then this other one has kind of a bizarre wave. But let's just bring up the saw wave. As you can see, does exactly what you'd think. Now we'll bring up the other input. So you can see that the signal is mixed. There's not much to do with a mixer except mix. So I'm going to do something else here. I'm going to show you the clip function. So we're going to take the output from straight out and we'll go into clip. And now I'll bring up the input 1 again. See how it's clipping? Let me go back to the original one. That's what it originally looks like. This is what it looks like clipped. Let me bring up the sound a little bit. That's clipped. It's unclipped. And this is inverted. See how it inverts the signal completely? So that's it. Again, not much to a mixer, they just mix. It's a good mixer. 3-input little mixer in your rack is a useful addition to anything, and it obviously complements the rest of the components in the EDU series. So that's it. As you saw, a pretty quick build, and again, a really great manual to go with it. So even if you don't buy the module, go download the manual and read it. You'll find lots of great information. Hope you enjoyed the video.